We are channeling the company's artificial intelligence efforts into one recognizable organization, Qualcomm AI Research. Qualcomm invents breakthrough technology that transforms the way the world connects and communicates. Going beyond mobile chipsets, we're inventing AI technology that can be used across a wide range of products and industries, from mobile and automotive to smart homes and cities, ultimately changing the way people live for the better.
Machine learning has already entered every corner of the Qualcomm enterprise. I personally believe that Qualcomm is uniquely positioned to become a key player in on-device AI, which brings with it tremendous opportunities, such as increased data privacy for users, reliability of service, high speed and efficient use of bandwidth.
Today, machine learning algorithms such as deep learning use huge amounts of energy to power them. And as AI increasingly moves to low-power edge devices, energy efficiency becomes all the more important.
The challenge we face in the future is about squeezing as much as computation as possible out of every joule of energy. And Qualcomm has a long history of delivering technologies that do just that.
Our mission is to push the envelope of AI and machine learning in the areas that will significantly improve everyday life. We are asking challenging questions, like how do we preserve communication privacy? Can we use deep learning to compress videos? How can we eliminate uncertainty when making life and death decisions? And how can we use this knowledge to optimize Qualcomm chips that run machine learning algorithms?
Qualcomm AI Research is an inspiring environment where researchers collaborate, innovate, and share their findings with the world through high-impact publications. But we do so much more than just writing papers. We actually build AI solutions that are used in billions of devices. In your cell phone, your smartwatch, your drone, your car, and all the other innovative technology of the future.
So if you're interested in pushing the frontiers of artificial intelligence, machine learning or deep learning, and above all, if you feel passionate about the prospect of bringing ideas to life and impacting billions of people, then Qualcomm AI Research is the place for you.
Semua hal berangkat dari sebuah awal. Begitupun kami menjadi pionir. Memutar roda penggerak bangsa dan terus melaju. Kami hadir seperti sebuah keluarga. Dan terus fokus membangun perekonomian negeri. Menjadi yang terdepan, mewujudkan mimpi-mimpi besar. Dari atas awan kami terus bergerak dan berinovasi, melihat negeri ini tumbuh dan berkembang. Inilah kami yang tak akan pernah berhenti, mengantarkan Indonesia ke puncak kejayaan. Karena dimanapun dan kapanpun, kami selalu hadir melayani dengan setulus hati.
History, most of the time, is born out of the simplest of acts, just like the birth of our story, starting with the pursuit to close the distance through voice, and make exchanging of informations at your own fingertips. And who could have known that was just the first step of our long journey? We had to jump even higher, to open new dimensions of opportunities to explore the world. And we keep on transforming through different times so that we can bring joy and progress for all walks of life. The world is always spinning, just like the sun. Your loyalty in us has always been our light to keep on innovating. No more simple beginnings, further and ahead. We have to keep on running, for you, for Indonesia, with the same vigor that has been driving us from the day one we began our 55 years. Selalu ada untuk Indonesia.
Assalamualaikum, Ibu Emma. How are you? Nice to meet you.
It's nice to meet you. We'll be starting in about 1 minute, I think.
Yeah, sure.
Okay. Hi, everyone. Good afternoon. Welcome to the final lecture session today. I hope all of you are doing fine. My name is Emma Rahmawati, and I'm a lecturer in Telkom University. I will serve you today as a moderator for this session. I know that this week has been very great to you all and tiring all at once, I think, as in this week, all of you have been learning all about machine learning in only 7 days. What a busy week. So, as this is Sunday, holiday actually, just sit back and relax and enjoy the lecture today. This is the final lecture in the MLSS. This afternoon in this session, we were gathered to enjoy a talk from Muhammad Haris about image super resolution and its application to computer vision tasks. Please allow me to introduce Muhammad Haris first. The next slide, perhaps. The host, the next slide, slide which is showing the short CV of our speaker. Sorry for a bit technical problem here.
I think that's fine. Maybe I can start to introduce by myself.
So for the participants, don't forget to, before we're diving in the lecture from Muhammad Haris today, drop your question in Slido. So today we will be using Slido for the question and answer session. Don't forget to drop your question. So Muhammad Haris, I'll turn it over to you now.
Okay, thank you, Bu Emma. Let me share my screen first. Okay. Is that okay? Can you see my screen now?
Perfect.
Okay. Okay. Good afternoon, everyone. So I have actually several people maybe already met me on the previous sessions, talking about the paper writing sessions. But this time, let me introduce or explain my research actually related to super resolutions and its application to computer vision. And my name is Muhammad Haris, and currently I work at Bukalapak. So since I already prepared my a bit briefly background, education background, and also experience, I graduated from University of Indonesia, Bachelor of Computer Science, and then I continue my graduate students at University of Tsukuba. And then I work at Toyota Technological Institute as postdoctoral researchers. And now, just this year, I started to work as AI research manager at Bukalapak. So this is our topic. Let's see some short video. I'm not sure, can all of us hear the sound or not?
Excuse me, Mas Haris, can you share the sound from your computer?
It's not, you cannot hear?
Yeah, we cannot hear the sound, yeah.
How to share it, actually, I'm not sure how to.
In the share the screen.
Share?
Yeah. Um,
New share?
no, a share sound system from your computer.
Cannot find the menu actually. but that's fine, I think. That's fine. Maybe wait.
Reshare the screen. Can you?
Reshare the screen. Okay. And then
Is
share
there any
screen.
option to share the sound?
Ah, I see. Okay. Okay,
Yeah.
I saw it now.
Okay, thank you.
Okay.
Okay. Now let's get a good look at you.
Is it clear?
Hold it. Run that back.
Wait a minute. Go right.
There, freeze that.
Full screen.
Okay, freeze that.
Tighten up on that way.
Vector in on that guy by the back wheel.
Zoom in right here on this spot.
With the right equipment, the image could be enlarged and sharpened.
What's that?
It's an enhancement program.
Can you clear that up any?
I don't know. Let's enhance it.
Enhance section A6.
I enhanced the detail and...
I think there's enough to enhance. Release it to my screen.
Enhance the reflection in her eye.
Let's run this through video enhancement.
Edgar, can you enhance this?
Hang on.
Okay, I think that's
Working on
enough
this
probably.
reflection.
So much reflection.
Actually, I just want to share because I know all of you may be already very tired along the summer schools, and it's been a tough week. And me, I got the chance to present my work at the end of the summer school. So let's like go through the presentation slowly. So basically, maybe most of us already seen couples scenes in the movie, like a detective or some investigator, like they confidently say, let's enhance this image, zoom the image to see better quality of the let's say car plate or the face of someone or any other specific objects. So this is what happened for super resolutions. Basically, what we are doing is to enhance an image or video, increasing the resolutions, either the spatial and temporal resolutions. So I will categorize into three categories: image super resolutions, video super resolution, and space-time super resolutions. Image super resolutions and video super resolutions, focusing on spatial, increasing spatial resolutions. Image super resolution means we rely only on one image, one single image, and video it is assumed that we have set of image or frames. And space-time super resolutions, it means we have to increase both temporal and spatial resolution in the video. So let's start from image super resolutions. As the video that I shown before, let's say we have a very small image and then we want to enlarge the image. Usually, for example, like any methods, for example, bicubic or bilinear or any other conventional methods, we cannot clearly see the results, the object specific pattern that exist in the image. But by using super resolution techniques, it is already proven that we can clearly see clearly the objects, for example, how the stones pattern, how many flowers inside these images, for example, and any other details that are not visible if we see it on low resolutions. So I will just jump directly to my paper. Actually, it's called the back projection network for super resolutions. This focusing on image super resolutions. So it was presented on CVPR 2018 and won several several challenge on image super resolutions on 2018 and 2019. Here, if I can go back a bit, how to motivate maybe majority of the audience is students. I hope if you are able to create or develop some algorithms, I really encourage you to submit those algorithms to some challenge, to some competitions. It gives you more highlights to your algorithms, not only based on the publications, but also if you compete in the real world, compete with state of the art, it will give you more impact and people will start to recognize your work. I think it's a good, not only that, but also you will have experience, I think, experience in competing with other people within your field. And I will start what is the difference of our networks with previous work. The first we can categorize as predefined upsampling. Predefined upsampling means the input image itself already interpolated by, let's say, bicubic or bilinear, some other predefined filters. And then using convolutional neural network, CNN, you need to map the details. You need to map the nonlinear details between the input. We can say maybe here the input can be middle resolutions since it's not really high resolution, but the size only in the same size of the what we are targeted. So the main job of the CNN here to fill the details without increasing the resolutions. But the disadvantages of this network, first, it will cause you high computations because the input itself is already high resolutions, the size, and there is some trade-off if the interpolation, the predefined interpolation miss something or even give you some wrong results in the interpolations. So it will bring to your target results. That's why the B single upsampling is proposed. They will just exploit directly from low resolution image, extract all the features from low resolutions, and then at the last layer they will use upsampling layer. Either it is the convolutions, transpose convolutions, or any subpixels or subpixels modules, any methods that can upsample the low resolution features, and then they produce the high resolution images. And the C here, C is actually extension of the B methods. Let's say, for example, if we want to enlarge 8 times, they increase the resolution by 2 times, another 2 times, another 2 times, until they got 8 times, which is increasing iteratively, gradually, to have better linear correlation between each scale without burden the network. So directly go to our idea. What is our basic idea? Let's say if we have L, which is low resolution images, low resolution image, and then we want to enlarge to high resolution image. It means we need to fill the blanks. We need to fill the pixels values, and first we can also, of course, we can copy the pixels from existing from the input low resolutions, but still we need to fill the blanks if we want to enlarge. So it means there are many possibilities in here, and basically super resolution categorized as inverse problem because it is from low resolution domain to high resolution domain. So ill-posed problem means you need to optimize, and there is no exact. It is very hard to get the real. So it is you cannot get the real solution for this this problem. That's why it is hard to optimize age? What is the criteria of the best results that we can get? Here, that's why we came up with some idea. Let's say, what if we downscale the age? Downscale the age, and we have another L hat. And if we can assume by this downscaling process, if L hat is relatively the same with L, it means H is reasonably good. And it means you didn't destroy the information, at least from the existing in the low resolution domains. That's the simple idea, actually. But instead of doing it in pixel domain, which is represented in here, what if we try in features domain instead? So we can exploit the deep learning benefits by using this. So that's why now we come up with this network, which consists of up projection and down projection modules, which shows roughly the same intuitions. The up projection is basically upsample the input, low resolutions to higher resolutions, and the down projections, it projected back the high resolution input to low resolution input. And then we have this set of iterative up, down, up, down, up, down until certain level. And what we really care most is the high resolution, of course. Then finally, we can get all H feature maps and then concatenation to finally reconstruct one final images. Here we can see that why up and down projection really works. The other intuition also, up projection and down projection, will simulate all the feature candidate for example, if we have set of low resolution features and high resolution features, like we need to correlate between each features, which features is really high correlate with the high resolution features. By having many of up and down projections, it means we have very huge, we augment all the features that are possible for this input image to generate the real, the most maybe closest to the ground truth, a single image per resolution. That's why the set of these up projections, the deeper, the more we have a combination of up and down projections, which also present the mutual relation between high resolution and low resolution features. This is what happened inside the up projection and down projection unit. So up projection, as I said before, the input is low resolution features and the output is high resolution features. The refined high resolution features, it means like first the input is low resolutions, we upsample to higher resolutions, and then we downsample it again, and we check, is there any consistency between the initial low resolutions and the reconstructed low resolutions. And the error reconstruction, E here, E is the error reconstruction residual features that we can use to refine the initial high resolution features. It's also the same for down projection unit, just the opposite steps. The input is high resolutions and we want to generate low resolution feature maps. Also the same, the downscale, upscale, we check the error reconstruction and then we feed it back all the error reconstruction to the initial low resolution feature maps. So just directly go to the results here. We go to 8 times enlargement. 8 times means if we have 10 times 10 pixels, it will enlarge to 80 times 80. So it means 1 pixel, we need to generate another 64 pixels for 1 pixel. So this is the input image, low resolutions. It's very hard to see the pattern, real pattern of the low resolutions input. And once we enlarge with super resolutions, it's most of it will give you better representations. But the interesting one is majority of the previous methods will give you wrong pattern, like Laplacian SRN and EDSR. If we compare with HR here means the ground truth. It gives you different pattern. For example, the first one, it gives you diagonal, not the horizontal and vertical. And also the second one and the third, also interesting actually, because the high resolutions, it's circle holes actually, not like box. But if we count the total holes in our methods, I think it's the same with the high resolutions, the same with the ground truth. And also I try to apply with the animations data sets. And I really want to note that in our training data, we didn't use animation data set at all. We use all the natural image, but the result is very interesting. We can see that our methods can generate very sharp edges. It's really distinguishable between the objects and the background, like the first one, the hiragana character, the line, the red line, the white, and any other, and also the same with the second and the third row. And if we want to see in the whole frame, this is the input. This is ours. Here also, this is the input. If I can, maybe most of us will see there is only 1, 2, 3% here, but if we enlarge with super resolution, it turns out there are another 2% at the back. So in total, roughly, maybe here should be 5 people. And this one as well, the input, and this is ours. So basically, DBPN can improve the input image by quite large scaling factor, 8 times in this sense, but it can be also applied to another scale. So this one related to the journal that I submit. So the journal is basically the improvement of our methods, DBPN. So I submit to CVPR, and then we extend this conference paper to journal. We did some improvement. One of it is we can use recurrent DBPN with shared parameters. So we can assume that all the up projection is actually shared the weights, and the down projection as well. And we can flexibly, it's very flexible to change the depth of the network. Either if you want only to use only 1 up projection and 1 down projection, or 2, or any other depth that you want to perform. And also it can reduce the computation of the network, of course. And the second, and there is no need for the dense connection because everything is shared actually. So it's already optimized by the same weights. And the second improvement is we use transition layer. Instead of concatenate all the up projections, we just focusing on the last layer as transition layer, which accumulate all the low resolution feature maps. And then all the low resolution feature maps will be increased to high resolution feature maps. And then later we will reconstruct it to single image resolutions. Okay, that's all for image super resolutions. So we go to video super resolution first. Again, this is based on our work. My collaborator, Greg Stanarovich, and also Norimichi Ukita. And it's also submitted to CVPR 2019. The code also available. And again, I joined several two competitions here, video super resolutions and video deblurring. It is interesting actually, since even it is intend to solve super resolutions problem, but by using small modifications, we can use the same network for deblurring. Maybe I will explain that later if someone interested on that. So again, the related works, the existing deep video super resolutions. First, the simple one, temporal concatenations. Basically, if we have more context, why don't we just concat all the network to have the optimized super resolution results? Here we have IT, T-1, T-n, in order to enlarge T times them, SRT. So we use all the context. But the problem is we cannot explicitly model the motion or the dynamic motions exist in the video. So some of the network will not optimize, will not get the context of other the context frames, T-1, T-n. Instead, the network will focus on the IT, the target image, because it is very similar to what we really want. That's why here the second approach, temporal aggregations, they think, okay, let's have some different network, multi-scale networks, which really specifically each network will handle specific scaling. The first one scale, temporal scale. The second, handling the temporal scale with 2 contexts, and also the rest we can continue until n, for example. And then we can merge all of these features to produce the SRT. And the C may be quite popular right now, recurrent network, which really proven that it can exploit the temporal relations within the series of inputs. It also happened for the video. If we have video, it means we have a lot of frames. So let's say if we want to enlarge IT, we can input all the IT through T-n to increase SRT. But again, here the problem is we didn't explicitly show the motions, the dynamic motion that are changing in the, for example, IT. There is no explicit explanation about how big difference from IT to T-1. It's only give you the gradual informations, because it fit in iterative manners, T-1, T-2, T-3, until you reach T-n. That's why one of that what I want to highlight is instead of doing it sequentially, why don't we really explicitly give the motion informations from the target to the context frames? In this case, IT, how far it is compared with T-1, IT to T-2, and also IT to T-n. So F here presented as flow motions. So we know the movement of objects. For example, objects, if car moving T compared with T-1, how far it goes. And we can also see from T to T-1 how far it goes. So each concatenations will give you specific degree of motions explicitly. So if in some certain frames the motion is high, in the high magnitude, and maybe in some other frames it's very small, so the network will learn how to adapt to that dynamic change of motions. And also worth to note that the blue arrows here, the recurrent back projection also works as the combination of single image super resolutions and multi-image super resolutions. As we can see in the blue arrows, the input is only IT, single. It means single image per resolution, which is the target only. And the red arrows, it's represented for multi image per resolutions, or here maybe videos per resolutions. So combining these two contexts to improve the target image is we prove that it is beneficial to iteratively refine the IT one by one using each context. So some illustrations, for example, if we have the target image, we enlarge by using single image per resolutions, it is still blur. It's not really give you the fine details. But let's say if we have another context, let's check in this context, T-1, for example, what are the missing details that we can collect from that frames, and also T-2, for example, this is the difference. Let's apply it to the target image, and also T-3, what is the difference? And then again, we apply to enhance the image. So basically, it is really iteratively refine the target image using the context. And this is what happened inside the projection modules. I think maybe I will skip this. Maybe but it's not really difficult. So for example, like encoder, the target block and the neighbor block, L, the input L is low resolution image. M, it means it is the multi image per resolutions, which is the concatenation of the target image with the context. So that's here the minus the difference. We check the difference of high resolution feature maps from the M, and also high resolution feature maps that are generated from the single image per resolutions. And then it's almost the same concept with what we are doing in the deep projections modules, if you still can remember. So basically, we generate the error reconstruction, and then we feed it back to either initial target output from target block. And the decoder of the task of the decoder, basically, the input is high resolutions, and we transform it back to low resolution feature maps. And this is some ablation studies that has been done. It shows if we use bicubic, it's roughly PSNR is 27. And by using DBPN, we have almost 30 decibels. But by using RBPN, the more context you use, the more it can increase the performance. Like for example, here, RBPN/2, it means RBPN with 2 contexts with 2 additional frames. And so in total, 3 frames was used. There is quite big jump, almost more than 1 decibels, and then add another one, until 6. Actually, I did try until 10 actually, but it's finished after the deadline of the submission, so we didn't put it in the paper. But the trade-off, it's not really good to use 10 because it's really high computations. I think 6 it's more than enough to give a good performance, because the more context we use, the improvement is not that big. So here, if we see the results, you can see by using 2 contexts, 3 contexts, 4 contexts, 5 contexts, 6 contexts, until 6 we can get the good, maybe very close to the ground truth. Here's some interesting comparison. I think we have a data set called Vimeo 90K. In that video, actually, there is no slow or medium or fast video category. So we did by ourselves to categorize each video, which video is slow motions, which video is normal or medium motions, which video is very fast motion, like action scenes or any others fast motions. So slow motions actually only consist of 0.6 average flow magnitude, so only basically less than 1 pixels happen in this video. So it's almost very slow and it's almost static. In the medium, it is very natural, normal video. So if we see the average flow magnitude is 2.5, while in the fast motions, it's 8 pixels. So there is from 8 to 9 pixels jump from some certain point to another point. So here we can see the more fast, the faster video frame rate, we have higher gap with the previous work. For example, here in the slow motions, the VSR DUF have almost 33 decibels, while we have 34. It means maybe a bit more 1 decibels difference. But in the fast motions, it is almost 2.5, I think 2.5 decibels difference. So what I want to say here, by separating the motions that what we are doing, concatenating the target and the context to each context, it will give better representations, better explicitly showing the dynamic motion that are exists in the video. That is the main difference with the previous work. And there is also worth to note that even using 3 context frames, RBPN/3-P here, we already outperform the VSR-DUF. So even using the less context frame, we already have better results than the previous network. So here some results, comparisons. This is the input. And this is if we enlarge with bicubic, there is no big difference actually. Even the blur is much shown in this image. If we enlarge with VSR-DUF, it is give better, but in somehow it's also give some noise. And if you focus on the breaks, here our results, we can give clearer and sharper image, especially to the pattern of the breaks. And also some other results here may be related to the investigator or detective movies. Let's enhance what is the text that are highlighted in the red arrows. If the input, it is almost, it is difficult. We can guess like Z, A, B, or something. But using bicubic here, it is, I think it is quite good using bicubic. Even just simple methods, it's still reasonably good. But this is the result for using VSR-DUF. That's previously I said VSR-DUF, even it is give you strong, sharper results, but it's in parallel also it generates some unnecessary noise, some noise to the text. And this is our results. So it can be seen clearly. It's Zabita 153. So our results can show much better than the previous one. So we go to the space-time super resolutions. As I mentioned before, space-time super resolutions, increasing spatial resolutions, and also simultaneously, we also interpolate the frames. So we did spatial interpolation and temporal interpolations. The paper is called STAR, Space-Time Aware Multi-Resolution Enhancement, and also it was submitted to CVPR 2020 this year. It should be held in Washington, but like MLSS as well, it's held virtually. And the code also available in my GitHub repository, so you can try if you are interested with this work. So again, related works. Let's say we have video super resolution. In A, we already understand it increase the spatial resolutions. And B, video interpolations. It means we interpolate the in-between frames. If we have LT and LT plus 1, we want to generate LT plus N. where n is from between 0 to 1. And our task is C and D to generate higher time and space resolutions. By seeing this, to solve this problem with existing methods, either we can do time to space super resolutions, which means we need to do time interpolations, the time super resolution first, generate them in between frames, and then we do the space super resolutions to increase all the frames in high resolution, spatial high resolutions. Or the opposite steps in D, we can do space first, space super resolutions. We increase the spatial resolution of the input, for example, 2 frames, and then by using the high resolution frames, we can generate the in-between frames, which is HT plus N. So the combination of the existing work, like 1, 2, 3, 4, it can achieve the same result as what we are intending. But instead of that, what we are trying to do is actually by jointly learning the multi-scale features. And the main important thing is actually the purple arrows, which bridging low resolution to high resolutions, which brings high resolution to low resolution in both spatial and temporal scale. So we can exploit all the directions of this graph, for example, and also exploit all the multi-scale features that are available. We can upsample and then downsample again. If you still remember, it's also it's the main idea of deep back projections previously. Upsampling, downsampling again, and see what happens until we have the set of HT plus N, and HT plus 1. So by using these multi-scale features, basically what we are seeing is we can estimate both large and subtle motions in one shot. Like, for example, in small spatial videos, the larger, the subtle motion will almost disappear, while in the large video, subtle motions can be seen. Maybe it can be represent much better than in what we have in low resolutions. And also the opposites, in the high resolution video, large motion might be difficult because the motion is very big and you need to calculate the motions in high magnitude degree. Well, that's why some people try to downsample the video, for example, to give more representative or more generalized or more, so we can see the whole context of the frames. That's why by using this multi-scale, we get the benefit of both criteria. So we go to this network. Basically, as I said, we have pair of low resolution and high resolution feature maps for each architectures, and then we enhance each low resolution and high resolutions to generate not only high resolutions images, but also low resolution in between frames. So in terms of input, we will have 2 input. For example, if we only care about 2 frames, and we have 2 flow estimation, 2 optical flow images, and we will produce 4 images. 1 low resolution in between frames, IL T plus N, and also all the high resolution super resolution frames. So let's go to the ablation studies. Here, for example, the methods 1, here only STSR means what is the effectiveness of these purple arrows. We can only, it's represented from method number 1. And we can also compare what if we add another blue arrows here in high resolutions. It's connect the high resolution features to each other, and also supported by the purple arrows still. And also we can also make the third options. What if we only ignore the high representations, just use the low resolution features, the another blue arrows here. And what if the full setup, is it works, or if we use all the representations, high resolution features representation and low resolution features representations, and also we can see the multi-scale representation from low to high resolutions. It shows that of course the full setup, the full number 4 is give the better performance, but it is interesting that using low resolution representations actually give better performance than high resolutions. We need to deep investigate on this actually, because it might be possibly there is also sensitivity to the test data that we use. For example, the motions, variation of motion that we use, because even it is better than, it's not that difficult. It's not that far difference, only less than 0.03, I think. So by using this schema, let me
Sorry for interrupting, Mas Haris. There are a lot of questions already in Slido. Do you want to?
I think I cannot hear Bu Emma voice actually.
Sorry. Right now, can anyone hear my voice clearly or not?
Now I can.
Okay.
Now I can.
There are a lot of questions already in Slido. Would you mind to start?
Okay. Okay.
Can you see the Slido?
I did not open it actually, but if
the first question with the most hot have from Wawan Cenggoro. He asked, have you seen the discussion on Twitter for the dataset bias for face depixelism? It upsampled Obama face to a white people face. What do you think?
Yeah. I add that actually. It's interesting because I see it as interesting result as well, because the input should be Obama's face, and then it's downsample, and then once we use super resolution network to upsample, it gives you totally different, even different rays. That's why people talking about this a lot actually recently. While me, I did not want to highlight specifically to the races, the racial bias, but more on it means the performance of the super resolution itself is really depends on two things. First, of course, the data. The more biased data you have, it will give you the more biased results. Of course, if you use only Western image, Western face, it will give you a westernized generated face. And the second one is related to the performance. It means because super resolution is inverse problem. As I said, there is many candidate of optimized results, but we really cannot choose which one it is. So there is really, if we want to use this super resolution technique, let's say it's applied to face detection, for example, it will give high sensitivity to this kind of bias. That's why it means in this field, we still have a lot of things to do to improve the performance, because roughly now, it started to, I mean, to interpolate or to enlarge an object, it is not really sensitive, but in terms of face, it's really sensitive because it's the face of someone. But if you want to enlarge a car, for example, it's only the shape. It's not really the character, the details of someone. So those two insights, I think that we can learn. First, the data. Yeah, I don't want to argue that, for example, the face datasets recently, the most popular, I think, Celeb A. I don't know, maybe people see it, majority of it use Western face or something. That's why it's generate something like that. But the second one, also the point that we need to solve. That's one of big question in our fields, I think.
Okay, thank you. One more question, I think, from Aryan Prabowo. Actually, we have a lot of questions here, but I think the most upvoting one from Aryan Prabowo. Do you have any tips for publishing in GVPR?
I think
hard work, I think.
Yeah, I cannot say. I don't know. This is maybe Japanese style or maybe specific for me personally. I saw myself as if we see the distribution of all people in the world, maybe only less than, I don't know, less than 10% that are give with the good, really good capability of understanding something easily, while majority 90% maybe need work hard, work harder than them. So me personally, I told this also, I said this also in my previous sessions. When I decide to submit to CVPR, I 100% focus only doing that during my research. Only CVPR. In my head, it's only CVPR. We didn't those yet. So all the experiments, we set the experiments, we see the pattern, how people explain their algorithms, how people write the algorithms, and how they design the experiments to analyze how to explain this algorithm works, and many things also will by seeing other people works. And basically it's all about also repetitions, and you write, you do the experiments, and again you will revise it again. Those iterative, it's really important for me personally. That's really important. That's why it's hard to say. Maybe some people really have their own individual experience. I mean, some people really like to finish the experiment first, and then writing maybe only takes 2 weeks or 1 week. But me, instead, I'm doing it with it maybe one year, everything together, making draft, experiment, making draft, another experiment. Even sometimes I really totally change the introduction section, and total. I mean, totally revise all the sentence. So it's journey. So you must have fun on that. Don't be burdened, even though it's need hard working. So yeah, that's what I can say, I think.
1 year for one paper?
Yes.
Oh.
But I remember that I think I have some bias here. 1 year, one paper after I graduate from doctoral degree. But during so it means maybe if you are experienced enough, at least you know what happened in your field. At least I think you know the related works, you know how other people works, and then you can focus on 1 year to develop yours. So, but if you really start from scratch, I mean you are really new to the field, Of course, it takes. I think it takes more time. It depends on you. If you're working harder, or or even I don't know if you are sometimes working harder will give you more chance to get luck. In maybe I don't know in some time you can get some idea, good idea, and then you can prove that idea works. So we really cannot guarantee that. The most thing that you need to guarantee is the work hard, work harder
Yes.
even.
Yes, because we know that the participant of this MLS is mostly come from students, master and graduate students. So I think the question is very normal. Do you want to continue your lecture or answering?
Maybe we can have another one questions.
Okay, this is from Chris. There are images that you show with various distributions. Do you train or eval on that particular dataset, or the technique is robust to out of distribution images?
Yeah, of course, the training and the evaluation and the testing using different set. There is some already general, general separations. This is the training data, and this is the evaluation data, and this is the test data. So like I said before, even we didn't use animation for the DBPN paper. There is animation test set, but in the training, during the training, we didn't use any animation images in the training sessions.
Oh, I see, I see. One more question, I think you should answer, because this is the question with the most upvoting from the participant. From Untari, do you have some tips on how to come up with ideas for improvement pre-existing methods for specific problems?
So the inspirations can be, for me personally, to write paper. Either you inspired by, you get idea to fix previous works. They have some limitation, they have some problem. You see that the problem is here. You can optimize this, or sometimes you have like totally especially for deep learning era, I think sometimes people directly get a new idea. I mean, out of nowhere, like not out of nowhere, but like by any chance you get the idea. But even though the second one, you still need to derive. I mean, there must be someone that has done this, at least not really totally the same, but similar to this. Or the third one, you open the new problems. You create your own problems and show it is worth to solve, and it can impact to this. And those are three things, three types of what you can get inspiration from. But all of it, I think, all of it will come if you read the paper on your field. It will, the main solution is, yeah, as I said, reading is the most important. Reading what happens in your field to know what really happens, what is the main things people discuss about. But you need to keep up with that issues, but you also need to sometimes see in different angle. I mean, not really need to be that frequent, because what I mean is sometimes you will really concentrate on one issues, but I think there is a chance that other issues is easily to be solved. Like object detection, for example. Every people will try to beat current state of the art object detections. If you just want to try to beat object detection, it will be harder. But instead, let's focus on some specific, let's see other perspective. For example, what happens if object detections, we need to detect an object on fast motion video, like specific domain, more specific domain that maybe not so many people doing it. So that different angle, you have big angle, and you see how can I move this problem to some other specific problem that has not been solved by other person. I think that's one of easiest way to do research. Uh, you always need to uh, have your own journey, read all paper, read not all paper, of course the one in your field. Joining the community sometimes also help a lot, like following someone in Twitter. You can follow someone that are well-known researchers on your field. They're mostly the US researchers or the other researchers. Usually they also discuss on Twitter. They sometimes retweet some interesting. As the first questions, it's that kind of bias is discussed in Twitter. So it's interesting actually.
Uh, two important keys, I think. Read a lot and hard work.
Yeah. Well.
Okay. As we only have 30 minutes left, do you want to continue your lecture first before we continue answering the question? Okay. Astrid, over to you now.
Okay. So maybe I will skip this part a bit, because STAR, basically what we are doing is increasing the high resolution, spatial resolution, and low and temporal.
Please reshare your screen.
I forgot to share my screen. Okay. Here what I want to highlight, maybe we have STAR, the general STAR network, as I mentioned, but also we can fine tune this network to specific tasks, because STAR solve all problems, space-time resolutions. Like I said, it generates high resolution feature maps, high resolution frames, and also low resolution feature frames in between low resolution frames. But we can also do care only star ST, for example. Let's care only on the high resolution frames without generating the low resolution frames. And also C, let's focus on only spatial super resolutions without any temporal interpolations happen. And also the D, we can also care only the in-between frames, the interpolations, the temporal interpolation from the input. So later we will see how it will affect to the results. Like STAR, it's generally shows 3 results. For example, IT plus means the in-between frames in super resolution domains, and IT plus L is in low resolution domain. So it shows that a specific, if we fine tune the models specifically to some particular task, space-time or spatial only or temporal only, it will further improve the performance. For example, STAR ST will have better results on SRT plus, and STAR S will have better results on ISRT, and STAR T will have better results on T plus, ILT plus. This one, maybe I will skip. Here, if we compare with state-of-the-art methods, it shows since there is no existing networks that did this jointly, we have to use our own experiments. This is one of the tips. If you want to be accepted to CVPR, make very comprehensive experiments. So the reviewer will not have any reason to reject your paper, I think. So we have covered all majority combination of the related works as mentioned here, and we compare with our star. It shows star ST will gives you better performance than other work. And also, if we compare only only want to see on spatial super resolutions, it's also again the same. We improve the performance by using star S. It happens also for temporal super resolutions. It beats the previous work, Dane example here, and also another related work. Here's some sample. It's not why it's taking. This is some sample of video results of STSR methods. I think my computer become heated now. I don't know why. That's why it shows some like to the video. But here maybe some frames if we want to see frame by frames. Focusing on the last row, we can see that the lack of the NBA players is generated. We can visibly see on our methods, while from other RBPN and Dane, we can see that it's not exist in, and also DBPN and to flow, it's not exist. That small, very small motions is sketched by our methods. So now we're talking about how super resolution can help to computer vision tasks. We already talked these super resolutions. This is super resolution. It can give you better, visually better image or video, but does it really help to computer vision, or we just increase the resolutions, burdening the computational time, but it will not improve the performance really well. That's why I did the experiments on that on 2018. Unfortunately, this one got rejected. So I got rejected on ECCV for this paper. It's interesting actually, because some people, it's quite, on 2018, there is no clear proof that super resolutions can improve the object detection task. But during that times, reviewer also some can argue that this is because the solution that we are proposing is quite simple. Let's just concatenate two network together and then optimize those two network together, and each loss will affect to another network, and super resolution loss will affect to the object detection network. So this combination of joint learning is what we are proposing to make the super resolutions become task driven. But even it is rejected, we just leave it on archive, but it's collecting some citations. So that's no problem. I will just explain it here. So how super resolution help computer visions? As we know, computer vision, the input is either image or video, and then we have some specific tasks, for example, segmentation, semantic segmentations, or object detections, or tracking, for example. But in terms of low resolution images, how we can we can improve the performance, as I mentioned. for example, in terms of aerial images, or here another paper called Fine Tiny Face, how it can detect very small faces. Then we need to analyze what is the role of super resolutions. And again, here, almost all of us might be already agree on this, that if we use lower resolutions, it will give you lower precision as well on the performance of object detection. So the lower scale you use, the lower performance that we can get. So it's really correlated quite high between scale and the performance of some tasks, for example, here in object detections. I did some previous results actually related to 3D reconstructions. We show that using super resolutions, it can improve the accuracy of 3D models. Although this is not deep learning, it's still optimized independently between the SFM and the super resolution module. The super resolution module still optimized using low level objectives, for example, like mean square error pixel-based loss, while SFM is not optimized on low resolution or on super resolutions images. But even that, even everything is done separately, it shows, it does give some improvement in 3D reconstructions. It gives you better details on the 3D reconstruction results if we see comparison with the low resolution image. But the question here, how computers see the image. As we know, the computer only see the pixel values from 0 to 255. This is what they are seeing. But instead of that, we see this. So it's different perception between machine and human. While machine previously, it's very low level representations, it's pixel based, while I don't want to see high level representation, but ours, human, is very, very, very high level representations. And it got, machine recently got boosting a bit, even though we still not know how it works, the deep learning, how really it works. But at least it gives you high level representation, which is in features domain. We really not focusing on the pixels, lost pixels base. By using this, it shows impressive increment, improve the performance of especially object detections. Year by year, it keeps improving. It's already reached 80%. I don't know, recently maybe almost 90 if we tweak or really fine-tune the model, the hyperparameter of the models. So we have these two representation, low-level representation and high-level representations. So what we are proposing by using these task-driven resolutions, we want to optimize both representations, low-level and high-level representations. Low-level on pixel-wise and also high-level on the features domain. So talking back to finding tiny face, this is what they are proposing. The input image. So the problem is to detect small objects, we need to use, we need to modify the anchor, the size of the template to find region of interest. The larger region you use, the more difficult you can catch small details. But the smaller size of anchor you use, you will not get, it will be harder for the network to detect a larger object. That's why they're proposing, okay, let's do some multi-scale detection. The input, it's increased to 2 times, and we also use the 1 times without any increasing, and also let's downsample it again, downsample it also. And then at the final steps, we can combine, merge all detection to the final detections. And it shows impressive results. It really works we can see it's very, I think the idea itself is very simple if we see only the result, only the final idea. But the journey, of course, it takes time. But if we realize it's basically what they're doing in the large size, it needs to detect the small objects. In the normal size, it will detect the what they are in the normal size, but in the lower, it can detect more on the large objects. So this combination works. They show some very impressive results actually here. Even they can beat, I think in some certain results they shows they can give the false negative from the label. So the label itself doesn't contain the bounding box of some specific phase, but using their network, they can detect that phase. So it's very interesting result that they are shows in their paper. It's 2017. From here, the idea is showed they only use some conventional interpolation, 2 times, 1 times, or downsample. So my question on that time, let's replace this to super resolution network. So that's what we are doing. So if we have small image, we enlarge the image, and we ask this input image to be detected on what are the objects that exist in the video in the image. So we have 2 network, super resolution network, and the task network, in this case SSD for object detections. And for the super resolution network, to make the network aware that that this network has to optimize based on some specific task, we can add the loss of the task, the object detection task, to the super resolution network. So so the error will back propagate to the super resolution network as well. So for example, we have loss of reconstruction, LREC here, and also LTAS is the loss of object detections, SSD from SSD. And we also have alpha and beta here. We need to balancing this alpha and beta to give which one will give you better performance. So here some comparisons. Using low resolution and bicubic, basically without any optimizations, it gives you 41 in average precisions on 16. And also we did compare with SR gun without any task. I think it is quite ambiguous. I cannot say low level optimization because SR gun did optimize by high level optimizations, the adversarial network, but it's not task representations, that it's not optimized by some other specific task. And then we can also see if we fine tune both models separately as SRFT fine tune with additional iterations, and SRFT plus with more longer iterations, and we compare with TDSR, our task-driven network. It shows that it gives around 10% improvement compared to the SRFT plus. So this is some results. For example, HR. This is the input image. If we feed the input, the high resolution image to SSD, it will detect motorbike, the person, and bird, even though that's helmet, not bird. So there is some wrong classes here. So this is the result of high resolution image. Then let's feed the low resolution image. In this case, 8 times. So we downscale the high resolution image to 8 times. So 8 times by 8 times. It's very small. It cannot detect anything in the image because it's very small. Then what if we enlarge the low resolution by bicubic? It can detect the persons, but not the motorbike. But if we use super resolutions, but not optimize on task loss, it detects motorbike, not the person, but the motorbike, the person becomes also in one with the motorbike. While ours, the task-driven super resolution, it can detect both motorbike and the persons. The interesting one is also PSNR results. It's also already common that higher PSNR gives you better image. That's what we see from if we use PSNR. It should be give you better image if it has higher PSNR, but not the case on this. If we see bicubic 21.26 decibels, DSR PSNR 22.02, but even though it is lower, PSNR 21.5, but it gives you better accuracy in terms of object detections. That's why here we can say that the correlation of PSNR and the accuracy of the task that you are, particular task that you are used, it's not correlate very well, because higher PSNR doesn't mean you will have better accuracy. Here for another sample, we can detect the horse effectively, and the bus here compared with the high resolution image. And there is another paper that are quite interesting on CVPR 2020 this year. This paper talks about joint optimizations, the dual super resolution learning for semantic segmentation. So what they are doing is jointly learning the semantic segmentations, while in parallel they'll also have the super resolution network to learn the higher representation, higher representations for the particular image. For example, here the input, it's fed to the network. The upper part is the segmentation part. The lower part is the super resolution part. So they will produce two output, single image super resolutions and also semantic segmentation super resolutions. But they propose one additional loss, which is calculated on feature domains, feature affinity loss here, to compare the similarity between the features from the semantic segmentations and also features from super resolutions. What are interesting here, in our methods, the super resolutions burden the inference time, because we need to perform additional computation for the super resolution network. But here it is not. Just they will optimize the network. Semantic segmentations will be informed how this image looks like on the higher representations. So this higher representation will give you better understanding how to segment the image. That's what they are doing. So during the test or inference, they are no longer use the super resolutions part. Just basically doing the same thing that needs to be done on semantic segmentations. They shows that using two methods, ESP-Net and also DeepLab, both network can be improved by more than 2%. For example, here, even in the small resolution, it can improve 5%, but majority may be 2 point something percent. But they shows in most of input size, various of input size, it can improve the accuracy of the segmentation results. There's some visual results here. You can see D can give better performance than C, and it's very close to B, which is the ground truth. The last the last row, the car is segmented very good in the D, while C is failed to segmentate the car, and also it's happened to other images as well. Yeah, that's all for my presentation. But the time is, I think.
Very well.
Thank you very much.
Haris, we have about 10 questions. We have only 6 minutes left.
Well, people still very, very, even though this is the last sessions, I thought we will have less questions, I think.
Perhaps I'll pick several questions from Slido. From Mamuku Windy Mokoe, which methods are used for downsampling or upsampling such that it preserves the important features of the images? What's the prediction accuracy on new images? Methods for downsampling and upsampling.
Well, there is many options that you can use, of course. For upsampling the methods, you can use transpose convolutions or deconvolutions, famously called deconvolutions. Or there is also another subpixels called subpixels. So they use convolution network, convolution layer, but they like how to say, like shifting, like instead of generating high resolutions, but you generate more low resolution representations, and then you combine all those low resolution representation to create high resolution. And for downsampling, many things you can do also. The simple one, of course, the convolution layer itself. Using some, you can modify the stripe. It will give you lower representations, or it's really there is no really best practice on this, but you can start from the simple one. It's really sometimes the problem of deep learning. You cannot say that this filter will work better on all cases. Yes, the larger pixel size, for example, will give you more large context, but in some other case also maybe it lose some details, or even it will burden your network so much because because it's very large filter size. Yeah, it's really, you can also like combination of some layer recently, or like deformable convolutions, or like combination of 1 times 1. I think 1 times 1 convolution is very interesting. I find it very interesting because it works like pooling, like instead of pooling, which is not really, I think pooling is not really representative very well, but 1 times 1 gives you, like, it enrich your features without increasing anything. It's like only gives you some certain weight, some more non-linear relations between each layer. So yeah, it's I cannot say which one best. It's based on the task.
Yeah. Which question I'll pick next, because we only have 2 minutes left. I think this one. In one of your paper, the anonymous as in one of your paper, you have added transition layer at the end to accumulate all resolution. What is the advantage, and where do you get the motivation?
Well, that's dense connection network, I think. Dense net. Yeah, it's basically imitate the dense net. And like what if the motivation is what happen if we applied apply dense connections to DBPN. Yeah, that's all. It's really simple. That's why sometimes you need to have strong contributions, and some trivial contribution is like accessories to your paper, which give you better confidential to be accepted. So yeah, this people have not tried. So you give them an answer. It really works. You show it works. Then that's why sometimes the idea you have to read uh, the paper related to your work, not really related to your work, even majority the best paper, for example. Even people now, I think previously argue the dense net. There is some argument on that because people show it's very trivial. I mean, like I saw someone say I did that. I think I don't know if it can become best paper on CVPR. so so sometimes you really, if you have some idea, sometimes the way you see the way you see it makes it trivial. But if you can see a different angle, you can explain it in detail, in sequential order, really shows the red lines, how it works, and how it can impact to some other works. It can it much better. I mean, people will see it. People will fully understand it. Yeah, that's how you can get idea, I think. So there's no motive. No, it's just imitate the dance style.
Okay, thank you, Haris. We still have some question left unanswered, but unfortunately the time is up. So sorry for the participant for the many questions unanswered. But and I don't feel that we have gone through 1.5 hours anyway, because this is a very interesting topic. Although this is the final session in this week of Machine Learning Summer School. And I believe that all of you, the participants, still want to discuss more with Haris about this topic. But unfortunately, again, the time is up and we have to end this session. So Haris, thank you very much for your time and for your sharing this afternoon. But please just don't leave soon, because right after this session, we have a closing ceremony. And we are very pleased if you can stay joining us in the closing ceremony.
Okay, thank you.
And for the participant, thank you all for attending this session and for your active participation. Hopefully this session will be beneficial for everyone. So, but please just don't leave soon. After this session, right away after this session, we have closing ceremony. Make sure you to visit the the closing ceremony right after this session. Again, thank you all for your participation. See you guys. Goodbye.
Thank you all.
Halo Bu Ade.
Hello, hello.
Hi. Hello everyone. Yeah, we are just go to the closing ceremony directly. It's not going, not a ceremony. Yeah, it's just like yeah, I just want to say goodbye and maybe want to show some things from yeah, this 1 week's events. Bu Ade, you want to start?
I think we should start with some announcement that to appreciate the participants. Okay.
Yeah. Okay. Right. Wait. I will share. Okay. Can you see the slide, everyone?
Not yet. Just the background. Okay.
Yeah. I mean the background. Yeah.
Okay. I think we should unmute all the participants.
Okay. Yeah.
Maybe
Wait. How to unmute the participant? Wait.
Yeah, it's okay. You can go continue and maybe Yuslan or Gugun can help to unmute all the
Someone
participants.
trying to unmute everyone. If you want to open your video, also your camera, yeah, you are welcome to do so. Maybe later we can take a picture. The last picture of all of us. Okay, I will show something before we really close the session. First. Yeah, I think you are all unmuted now. Statistics, a little bit of statistics from our 1 week lecture, practical, and other sessions. First, attendance rate, lecture and practical attendance rate is around 50%. This is actually not really low. Actually, we are already like expected. Yeah, expected this kind of rate. So when we decided how many participants, for example, how many members in a group, for example, actually we already think about this attendance rate, and we think that 50% is a reasonable number. So yeah, that's not really a surprise for us. 50% is still a good number for virtual events. And then the group meeting attendance rate is around 42%. Again, not very far from 50%, our expectation. And then mentoring attendance rate is around 60%, and more than 180 user logged into our website. We can see whether someone have ever logged in or not. If you never logged in, we know the status is never logged in. And in our Rocket chat, at least we have more than 3,000 messages. Yeah, actually that's quite good for us. It means that there are some exchanges, conversation in between the participants and also with us, the committee. Right. After the closing, there is something else that we want to share with you. First is the certificate. We are working to sending you the certificate, but we will ask you a questionnaire first. So after you fill the questionnaire, we will send you the certificate. And the program book, like I said before in the email, working to finishing the program book, and we hope to put your pictures there also, and the materials. We will send you all of the materials. Someone asked about the Max materials. I cannot really send you the materials yet because he warned me not to send yet. He has the latest version, but he hasn't sent it to me. So we will for that. Okay, and then the announcement. We have three kind of awards. The first one, the best poster. Okay, we have chosen 3 best posters. They are going to the first one is Tuan Anvu. The second one is Novri Suhermi, and the third one is Javier. Javier, right? Okay.
Let's see whether they are in this call. Maybe you can share your voice, Tuan Anvu, Novri, and Javier.
Yes, one of them at least, or who? Wait, I cannot see. Who want to speak first? Tuan, do you want to speak? Okay, I don't know. No free? You want to say something about this event? No free. I think you can unmute yourself, right?
Tuan cannot share his voice, so maybe some problem in the microphone.
Yeah.
Okay.
Well,
Nopri want to say
Okay,
something?
Nopri, yeah, please.
yes. Thank you for the award. I'm quite surprised that for that I become one of the best poster, and maybe I think this summer school is very good. There are many materials that is really beneficial to my next project. Maybe I hope I could participate in the next event like this.
Right.
Anyway, thank you very much.
Thank you. Javier, do you want to say something?
Hello.
Hello.
So yeah, thank you very much for this. Is an honor to have this recognition, and yeah, I mean it's been really a really big pleasure to be in this summer school. I think there's been a lot of really interesting lecture, really interesting tutorials, a lot of very well known people that have taught us a lot of interesting topics, really important things that I think can help us to to develop our careers in the future in machine learning. So yeah, definitely I think it's been really great to attend this summer school, and thank you very much, everybody.
Yeah, thank you. All right, the next award is I think the group. Tuan, okay, Tuan. No, I think something's there's a problem with Tuan mix, I think. Okay, we go to the next award. The next award is project. The best project ideas that we selected 5, the best 5, and you selected the best 3. So this is from your votes. The base proposal goes to group 3, group 6, and group 12. This is from the voting that we closed around 11 EM today. So congratulations for these 3 groups. I don't know whether someone from the group want to say something. You can just unmute yourself. No? Okay, wait. The group 3. Who is the group 3? Let's see group 3.
Yeah, we should check the participant in group 3.
Group 3, I don't know. Harald Bayer. Hi, Harald. Can you speak?
Yes. Hello, I can say something.
Yeah.
So yeah, thanks to all. I'm happy that you found the proposal interesting. Especially thanks to the organizers. It was a great summer school. Thanks for organizing it despite the circumstances. And yeah, thanks to my group mates.
Yeah.
Came up with most of the proposal. Yeah. Hope to see you all in person at some point.
Right. Yeah, maybe we have like an in-person MLS next year. I don't know. Let's see how it goes. From group 6. Who is from group 6? Someone from group 6? At least the one who sent us to our email. Who sent the proposal to our email? From group 6. I don't know. I can find it, but yeah, I think we can just
Ali Weekends, Lia, Smriti, Arif Koderi. I think some of them is in this call.
Arif Kodari. Arif Kodari want to say something? No? Okay. Lia, right?
Yeah, Lia Anggraini, yeah.
Lia Anggraini? I think she's not in the group now, in the Zoom. Or yeah, we can just go to the group 12 because maybe we we don't want to take too much time. Group 12. Anyone want to say something from group 12?
Oishi
Yeah.
Yeah, hi. Hi, this is Oishi from Group 12.
Okay.
So thank you for this wonderful event. And I think the idea of the group project was very good because I got to network with the fellow participants and we got to like ideate over calls, set up meetings and talk about machine learning and about some the theme of the project and make the slides together. So it was a great idea to collaborate and network in this virtual setting. So, and thank you for I'm glad that our proposal also got selected. So thank you.
Thank you. Thank you. Okay, and the final award is for the most active participants. So how we choose these 3 most active participants is from the chat, from the Rocket chat. So we just create some, just simple algorithm just to count how many you write something on the chat. So as simple as that. And of course, we also cross-check whether you attend the group meeting or not. So if you highly active, but you did not attend the group meeting, so we have to cancel it. So a group meeting is just, one of the most important to be chosen as the most active. And in fact, the most 3 active people, they all attended the group meeting. So this is the most active participants. Cheng Wawan Chenggoro, I think. Sorry, I think there is a typo there. And Rian Adam Raja Gede and Georgios. Sorry if I mispronounced your name. Georgios Folgaris, I think. Thank you so much for your participation. If you want to say something, you can just unmute. I don't want to push you because I know you already an active person, right?
Yes. Hello, can you hear me?
Yeah, Wawan, please.
Okay, so this is really a wonderful event. I still can't believe that actually that I can really drop an email to Max Welling. That's wonderful. That is kind of like my goal actually, and I don't hope it comes true, but it really comes true.
You mean you send email to Maxwell?
Yeah, if you remember that in the last lecture or from Welling,
you asked him
a topic and ask him whether can we discuss it on email, and he just say yes, and whoa, this is wonderful.
He is actually a very nice person. From personal experience, he is a very nice person.
So I think that it really opens up our eyes that really collaborates between researcher. It's not really something that is impossible. It is possible. And we should, in the developing country like Indonesia, and we see also a lot of people from Africa, really should do something like this a lot. We need to talk to each other frequently about the development of our field. And let's just replicate what we really do here in a large scale, the computer language in a large scale, so that really we have finally we can have a community for research. This is what I really miss in Indonesia. We don't have that kind of community that is really actively researching. There is some community, but really just for learning, I see.
Yeah, thank you so much.
Thank
Yeah,
you.
I hope you success with your collaboration with Max. Yeah, I don't know, Rian or Georgios? Georgios. Okay, Georgios,
Yeah.
please.
It sounds like Georges. It sounds
yeah.
like Georges.
No, you said it perfect the first time.
Thank you. Okay.
Yeah. And yeah, it was an amazing experience. It was obviously strange because of the time difference. You know, have to get up 2 o'clock in the morning, but it was amazing. I really enjoyed working for the team project as well, our group 12 that we got the third place. And I found it very interesting how we could use technology being so far away from each other and still be able to cooperate. The lectures were amazing and the practical session. And I honestly felt I was there. You know, I honestly felt I was there. It was a really good experience. And I really hope next year I will be able to be in person and meet all of you.
Yeah, thank you so much. All right, thank you so much for all, and I think the next slide is okay. Yeah, before after this, just some pictures from the lectures and from the practicals and so on. Maybe Bu Ade, you want to say something?
Okay, so I just want to share to all of you that we are very thankful to all the lecturers, to all the practical session speakers, and all the mentors. Actually, at the beginning, Max Welling is very, very nice, and he was and still really helpful to make this event to be held in Indonesia. So at first when this pandemic happened, and then we just feel that okay, so we think this is almost impossible to hold this event, but he ensured us that of course this is really a good time to hold this virtual event. So we can have more participants to attend, since there will be no travel issues. So yeah, just make this event happen. Okay, so we are very thankful. Even he helped us to participate in this event. So it will be a nice gesture from him to connect us to the speakers. You know that some of the speakers are very popular, and of course they are very busy. Opening email is not an easy task for them. Yeah, so just open email for them is, yeah, we just pray, and we think we should be very patient to wait, to wait for their email. So yes,
but they are very committed. Once they said yes, they never said otherwise.
Yes, that's true. And also for the mentors, mentorship session. So I found that some of you came up with the idea if the mentorship session could be recorded, but we think that maybe in this mentorship session there will be some information that should not be recorded. I mean that maybe they share something that really personal, or else that can be shared publicly. Okay, that's why we make the mentorship group in a small group and a private group. Yeah, so that's the answer for that question. if we want the mentorship session as an open session, and I think you can already get the answer from internet, but on a private session, and then you can ask, or you can hear a sharing session that you won't find in other sources. So it will be a personal sharing. Okay, yeah.
Okay. Yeah. Before we really close, I also want to hear maybe Andit want to say something.
Yeah.
Andit is our practical session coordinator. So yeah,
And
besides he also give the lecture, give the practical session, but he also coordinates all of the practical session. So yeah, thank you so much. Andit, you want to say something?
I just want to say that thank you for all participants. Their enthusiasm is really made me happy. There's so much question, and I hope that all the practical session will help you. And I don't know for how long the websites will be up, but we will all the practical materials already updated to the GitHub, and we will also later compile the all available resources that can be shared also on the GitHub. I think that's all from me. Back to Said.
Yeah. No, I don't think I'm not here, and also we also get help from some of our students also that really helped us in manage everything. And yeah, one thing that I really want to again to thank you all is your participation by asking questions. If you remember from my first email that I sent to you, that I said please ask questions, because that's one thing that I really worried about. Whether students will really participate or not, because otherwise it's not like a really good lecture, right? Because if we only have one-way communication from the speakers, then yeah, it's like a burden for us, for the organizers. So thank you so much. Thank you so much. That's all. The things that I was really worried about. That's from me basically. Some of you sent us emails and also private chat that say thank you personally. We are really appreciate it, and the things that really matters for us is your experience, your good experience in this MLSS. That's basically what I want to say. I don't know, Bu Ade?
Okay, I just read a chat from Rian that said he just want to practice his English and make new friends. But I think you got it. Yeah, you get that opportunity, and I think that's also important motivation to attend this kind of event. Okay, since you meet the participants from all over the world, and of course we try to encourage all of you to actively participate. So I hope that you can take advantage of the networking session and all of other sessions.
Okay, there is one participant who would like to say something. Mustafa, can you speak?
I just want to thank everybody. This is a very good opportunity, and I'm into machine learning field, and it's giving me a lot of privilege, a lot of opportunity to meet our lecturers and most of advanced people in the field. This has really boosted my confidence, and I must say, like as it is right now, it feels like I should finish my PhD tomorrow, because I want to believe that I have all the ingredients to help me out, it's been a wonderful thing working with my group. I'm a member of Group 16, and we had quite an interesting section. You know, it was very, very good. It's unfortunate that our project didn't make it to top 3, but I must tell you, we are winners in that group, and I hope we can foster collaboration. Thank you very much to all the hosts of MLLS. You guys have made it so wonderful. And I hope that we can meet one day, someday, and collaborate. Thank you so much.
Thank you. Thank you. Yeah, there is a question from Muhammad from Malaysia, I think, right? Asking about the next year summer school. I cannot answer it right now because it's not really easy. We cannot say it's really easy to create the summer school. The summer school was started from last year, so our process is from 1 year before the event. So it's very, very long preparation to really create this just 1 week event, especially about the speakers. So it's like quite a long process, but I don't know. Max Welling said he want to go to Indonesia next year, right? Because he already booked the vacation. He really wanted to go to Indonesia this year, actually, and he already booked the vacation to Indonesia. Let's see next year if there is another MLSS Indonesia next year. Then I will tell you at least from the email.
And maybe the next year the closest in terms of area, I think there will be Southeast Asia that will be held in Vietnam.
Vietnam. Southeast CMLS probably is going to be held in Vietnam next year. Actually, it should be held this year, but they postponed it. I recommend if they really hold it next year, I recommend you to also participate in CMLS. I was a participant there at the first CMLS, and it was a good experience. Javier asking about the actually Ade already answered it. Okay, Ade, anything else?
No, I think this so I want to say sorry for some technical glitch. So at the beginning also we expect some of technical glitch, and of course we are very sorry for that, and that's all.
All right. Okay. Basically that's all from us. It's 30 minutes, right? It's already 3. So basically that's all from us. We thank you so much for your participations, and see you when we see you, right? If we meet somewhere, just say something to us. Maybe you know us because I was always on the screen. So okay, that's all. Thank you, and maybe some of the picture from the previous
should we take a picture
together? Yeah. That's correct. I always forget. Anyone want to take a picture? Please open your camera. Please wait. Okay, maybe this is the last picture, and if you want to be put on the MLSS program book, please send us your selfie picture with maybe unique background around your home. All right, this is the first page. 1, 2, 3. Okay, let's go to the second page. This is the second page. 1, 2, 3. Okay, because I think only the second, because the third and the fourth is without a video.
Okay. Yeah.
All right. Yeah. Thank you, everyone.
Yeah.
Bye-bye.
Bye.
Bye, 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 bye,
Bye.
Bye. Thank you.
This is Max Welling, Ian, if you remember, and this is from Ferial. This is from Daniel, Slide, Vincent, and this is from Opening, and finally this is our best camp. So this is one, from this 1 week.
Don't put best picture.
Yeah.
Don't put that picture, please. No, just
awesome.
Yeah, that's our working space for this whole 1 week. Thank you so much, everyone. Bye.
Kita nggak 6 digit kayak